Okay, hello. Little bit of early morning. Actually, I guess you can't tell it's early morning, but a little bit of early morning coding practice, coding interview, whatever. um, so basically, uh, this is near the end of the K-way merge. Um, what is it? What do you call this? K-way merge coding pattern. Um, so I guess it's kind of cool. Yeah, I guess we'll just get into the question. I don't know what else to say. Given M sorted arrays, find the smallest range that includes at least one number from each of the M lists. For example, if we have list 1, 158, list 2, 4, 12, list 3, 7, 8, and 10, what is the smallest range? The smallest range is 4 and 7 because, well, it includes the number 5 from list 1, and then, well, obviously 4 and 7 from list 2 and 3. So, yeah, I guess we want to know how to do that. So let's get into it. Be doing a little bit of imports. We're gonna import heap key. We're gonna import everything, and we're also going to import math. So, since it's a K-way merge, we need a heap, right? So we're just gonna define our heap. We're gonna make we're gonna initialize a few variables here. Range start, range end, and a current max. And then we're going to start range as 0. We're going to start range end at math.infinity, and then current max is negative math.infinity, because whenever we want to count the max, we want to start from a negative infinite. And then our range, the reason why this end, even though it's essentially like the max value that we can have out of here, we started at infinite because we want to work our way down. We want to make our range smaller and smaller, right? And so we need to make them on both extremes. You could theoretically make this negative math infinite as well, but I don't know, maybe that's a bit too much because technically this is already an infinite range, so you don't need to lower the 0 down. So we got to populate our heap, right? So kind of the same thing that we've been doing this whole time. For I in range of the length of the list, we want to heap push onto our heap. We want to heap push the lists I and 0. We're going to push on the 0 for the index at which index we are currently looking at in the list, and I for the index of the list, right? And then here we're going to be calculating our current max by using the max function, comparing current max with current max, of course, and list I and 0. So basically, current max is going to represent our top side of the range, like range end, but it's not finalized yet because this can keep changing, right? Just as how range start and range end can keep changing throughout this question, our current max will be changing as we, go through. And so, right now, so the reason why we use this current max is because we'll look at example 1, even though we only have like 2 solutions here, or like 2, I guess, questions that we'll run just to verify if we're getting the right answer or not. So current max starts at negative infinity, and as we go through these 3 lists, we pop on the first index, right? And so we now know, like, whatever is the maximum here, we will have included something from all of the lists, right? Because here 1, 4, 7, if we include 7 here as our current maximum, we would have included everything, and I guess technically you would want negative math infinite here. But since we haven't set any of these variables yet, it doesn't really matter. This is just like for like going through and building our solution, right? So current max of a 7 will include all of the answers from list 1, 2, and 3, right? So that's what our current max is for. And now in order to like actually start setting the values of range end and range start and range end, we're going to create a while loop. And typically we do this, we have our while loop based off of when the length of the heap drops to 0, but instead we need to have a condition where the length of the heap is actually equal to the length of lists. Because once we completely finish off a list, and if we keep going through, we could effectively make our range lower and lower. However, we wouldn't be satisfying the condition where the smallest range has to include at least one number from each of the lists, right? So if we start going like too small, and we only start dealing, like for example, if we start only dealing with 2 lists, so this list would actually be finished first because the largest number here runs out before this. So if we only start dealing with these 2 lists, then we will not, it's possible that we don't satisfy the condition where like at least 8 is included, right? So that's why our while loop like exit condition is while the length of the heap is equal to the length of lists. And so we're going to do our typical like pop off stuff, right? So number index list index is equal to heap pop off of the heap, because we have 3 things in each of our tuples in the heap, right? And so if range end minus range start is greater than current max minus number, like this number here, then we'll set the values of range start to equal number, and range end is equal to current max. Yeah, because this just shows that the range that we currently have here is not as much as whatever we have built so far for the final answer, so we need to reassign the range for our final answer to become that smaller range. And now we need to determine whether or not we want to keep pushing, if we want to push this list back onto the heap, right? So if our current index in the list is not at the very end, so if there are still more numbers, then we need to push it back on, right? So basically, if this is shorter than the actual length of the list, then we can push it back on. So we want to heap push onto the heap, list index plus 1. We're going to push on the second for the index plus 1, and then list index, because the list index doesn't change. And we actually have to reassign current max, because it's possible by changing one of these values, by pushing on like this value, it would have changed the maximum that we have currently, right? So let me write this out, and then I could find a situation in which it actually does satisfy that condition. Just make sure list index, we want to push the value, and we compare the value to current max. And then if we just go to the very end, that will have satisfied all of our conditions, and we just have to return range start and range end. So basically, let's find a condition where this will be satisfied in this, right? So we have 158, 412, 7, 8, 10. Okay, maybe that's not the best example, because our final answer does actually use 7. Actually, it should get replaced, like it gets replaced once, but then we maybe just don't go back into the while loop. So we'll see. So 158, 412, 7, 8, 10. That's on our heap, right? We pop off this one because 1's the smallest. We look at this. Our current max right now is 7 because of this. It is smaller. 7 minus 1 is smaller than 0 and infinity. So we get 1 and 7 for our, you know what? Let me write it at the bottom. Range start is equal to 1. Range end is equal to 7. Right? And then so we look at this. 5. We do have more things in the array. So 5. we push that back onto the heap. It's not the max because 5 is less than 7, so we go back in because we still have 3 lists. Now the next number is 4, so we take out the 4. Current max is still the same, 4, 7, so that's a smaller range, so we update that to 4. We do have another number, 12, so we put that here, right? And then, so now 12 is the largest, though. Actually, we should probably have a current max. So it was 7, right? But now that we pushed 12 as the first value of this list back on, current max is now 12, right? And so now, we pop off, it'd be 5, right? Is that the number? Yeah. Yes. We pop back on 5. Or like we pop off 5, I guess, right? And then we go here and then we get, what is it, range end. So our range end is currently 3 and current max is now 12 minus 5, which is 7. So that we don't get that, right? And so we push the 8 back on, still less than 12. And now we pop off the 7. 12 minus 7 is 5, but this is 3. So we don't do anything, so we push back on the 8. And then so this 8 will come off. And then we do 12 minus 8, 4, which is still greater than 3, right? And then so now there's no more left in here, so we don't push it back on. And since we don't satisfy this range anymore, we just return this. So that's I guess even a trace through. I wasn't expecting to do a whole trace through, but I guess that happened. So we already know the answer to this is 4 and 7, right? Because the explanation's here. For this one, the smallest range will be, what is it? Okay, so I guess essentially the biggest one would be 1 and 16, right? So 1 and 10 would still work. 4 and 10 will still work. Is it 4 and 10? No, it's not. Oh, it's 9 and 12. Lol. Yeah. Okay, that would make sense. Because what? Did I say 4 and 12? 9 and 12. 9 and 12 because that also includes the 10. Yeah. Okay, 9, 12. So yeah, that's what we should expect out of running this. So if we were to run it now, you get 4 and 7 and 9 and 12. So yeah, guess that's it. Thanks for watching. See you guys next time.